welcome back. So now that you understand what's involved in a twitch, a single muscle twitch with the 4 parts of it, the latent, the contraction, the relaxation, and the refractory period, let's look and see what happens physiologically in the body, because as we said before, no one twitch is causing a muscle contraction. So the response of the muscle can be graded, what can be altered, what we call gradations. And the way, so in other words, it's the entire muscle contracting. Is not that it's contracting one time all the way or nothing. And so we grade it by looking at 2 different things. We can change the frequency of the stimulation, okay? So change how often there's an action potential to even cause a twitch. Or we can change the strength of the stimulation, which has to do with the number of muscle fibers contracting. So let me show you how these work. Okay. And in all of these, it's very important you pay attention as you go along to see what the muscle contraction looks like. Is it starting at threshold, going fully, coming back down the threshold, or what's happening? So what we have to look at first is the relationship between the voltage and the tension that's generated. So as we talked about before, we can have stimuli that if we don't reach this threshold, we have no contraction occurring. And so in the middle is showing what proportion of the motor units are excited. 0. Then all the rest of these contractions being shown, they have all reached the threshold. But what you notice is in each of these 4, 5, 6 to 7, the stimulus is getting higher and higher and higher. Actually, from 1 through 10, the stimulus is getting higher and higher. But after, or starting with number 3, we're actually starting to have a muscle contraction because we have reached the threshold. So once you have reached the threshold, if you have a stronger, measured by voltage, stimulus, then you are going to have more motor units being activated, giving you a stronger contraction. And so as the stimulus goes up, the contraction goes up until we reach a level that's known as the maximal stimulus. Once you have reached the maximal stimulus, what you will see is 100% of the motor units are excited with that maximal stimulus, which means we have now reached the maximum contraction that can occur. Increasing the voltage past that does not give us a bigger contractile tension or force generated. Okay. So that's the first thing to recognize, the relationship between the voltage of the stimulus and the tension of the muscle. The second concept has to do with recruitment. Muscles have different sizes of motor units, and that allows them to adjust. So, for instance, an increase in force can happen if we increase from just 1 motor unit being stimulated to having 2 motor units stimulated. So an increase in number of motor units. Okay. And this goes back to that shift work we talked about before, so we can sustain the contraction with minimal fatigue. And so this is showing stimulus X, which only stimulates 5 fibers. Stimulus Y stimulates 7 fibers. But if we activate both of these motor units, then we would have 12 fibers being stimulated, giving us greater tension. So this is also known as multiple motor unit summation, although most people just call it recruitment. We're just adding or summating. We've got, if this motor unit has 5 cells and that motor unit has 7 cells, if we add the 2 together, that's multiple motor units, as in 2 or more, and we are summing the number of cells being activated or recruited. The next concept has to do with twitch strength and frequency, because the strength of the twitch can vary with the frequency of the twitch. So if we have a high frequency stimulation, that can give us stronger twitches. So if we look first at low frequency, for instance, only 5 stimuli per second, here's the twitch, or here's the stimulation in red. We have a single twitch after each, and then we have another stimulation, we have another twitch. So this is a low frequency, in other words, not that often. And every stimulus will give us the exact same twitch, because that muscle has had a chance to contract, to relax, go through its refractory period, and it's back at threshold, ready for a new latent period. Okay, so that's what happens at low frequency. Now, this is what happens also when you're first starting to use a muscle. If your muscle has been at rest for a long time, we are going to have a phenomenon known as treppy. And what that is, it shows what happens as the muscle warms up. When you look at the left side, what you will notice is that the tension is increasing each contraction. But notice each contraction is going all the way back down towards the threshold. It's completely relaxing in between them. So the initial contractions are actually only generating about half the force of what happens after that muscle is warmed up. Thus, meaning like you need to warm up your muscles before you can eat, okay? And so this muscle tension increases just like going up the steps on a staircase. So it's a graded thing known as treppy. And the whole physiological reasoning for this has to do with, as we go along, when we get the stimulus, we're releasing calcium from the sarcoplasmic reticulum, but it's not immediately uptaken. So if you have another stimulus, some of that calcium is already there and can rebind to give us a higher amount of cross bridges being formed. Okay, so that's treppy. Usually only happens at the beginning of using a muscle as it's warming up. Okay, but we're having full contractions. They're just increasing in the tension until we hit the medium tension. It's the same thing you would see if you had lower stimuli getting stronger, but in this case, you are having a full stimulus. It's just that the muscle's not contracting fully at the beginning. The next concept goes back to the previous thing where we were showing low frequency, where we had the full time to reach threshold before we would generate a whole new latent period with another full contraction. In other words, if we increase the frequency to say 20 stimuli a second, remember I said twitches are normally somewhere between 5 and 12 times a second. So if the frequency of stimulation is higher than the muscle can fully relax, we develop something called wave summation, also known as temporal, because it's a time-related function. Okay. So to the left of the dotted line, we have a normal action potential, which generates a lovely little twitch, which comes back down to baseline, and then we hit a new action potential. And we are starting up, we have the latent period, we have the contraction, we are starting down the recovery when there is a new stimulus, okay? So we are out of the absolute refractory period, but only in the relative refractory period. So if we have a strong enough stimulus, we can add a second twitch onto the first twitch, where we are having a summation effect where the force of contraction is now higher than it would have been due to now we are recruiting more motor units. But notice in wave summation, we do not return to threshold between the two waves, as opposed to treppy, where we returned to the threshold between two adjacent action potentials. Okay, so that's wave or temporal summation. So now I need to talk about something called clonus, and there's no picture on this because there's different types of clonus, so there is no picture I can do to show you this. In clonus, what's going to happen is we're going to have our maximal stimuli, just like we showed in the temporal summation. However, each of these stimuli is going to occur during the mid-relaxation period, okay? So just like we're showing happening in a single wave temporal summation, and we'll see what happens. This slide is only showing two action potentials, one generating contraction and the second one giving a second twitch adding on to the first twitch. So now in clonus, we're going to do more than just two twitches. And in between each action potential, the muscle will be relaxing, but not completely, not getting down to threshold. So the first type of clonus is called incomplete tetanus, okay? And so when you look at this, this basically is a bunch of wave summations happening. The red arrows are showing the action potentials and the blue is showing the tension. So we have a wave generated from the first action potential. We're in the middle of relaxation. We have a new stimulus. So we are having calcium staying in the sarcoplasmic reticulum. So we're actually to have wave summation occurring on this second one. Trying to get my arrow going again. All right. And then when it is relaxing, we're having a third action potential. So we're having more wave summation happening. And then we're having a fourth action potential. We're having more wave summation. And so you see it's continuing to go higher and higher and higher. This is incomplete tetanus. So I want you to pause it right here for a second and figure out what's the difference between treppy and incomplete tetanus just by looking at the tension. Okay, so hopefully you understood that. So we are going to continue with incomplete tetanus giving us wave summation until the muscle hits the maximum tension. After that, we can't go to a higher tension, so we will have relaxation and new action potential brings us back up to muscle tension, start relaxing, back up to maximum tension, go back down, back up. And so we're going to have the sustained fluttering contraction that occurs in incomplete tetanus. So now let's figure out the difference between incomplete tetanus and complete tetanus. Okay, realizing incomplete tetanus, we've got wave summation going on until we hit maximum tension. Complete tetanus, what happens is the stimuli are much faster together. So we're going up in contraction. We don't have any time to relax whatsoever. So basically all those contractions are all fusing together. So it looks like one huge, super long contraction. So we have huge stimuli because we are in the refractory period, like we're up there at that maximum tension. We have just barely nanosecond crossed from absolute refractory into relative refractory. And so we are staying up there. So it looks like one long sustained maximal contraction, and that's complete tetanus. So both complete tetanus and incomplete tetanus, those are the two types of clonus. All right. And with that, we are done with our graded responses. So make sure you take a time and go back and review this if you need it. And I will see you again soon as we continue learning about muscle physiology. And thank you for all your hard work because I know this is a difficult time. The muscle contractions are tough.